Welcome to my presentation. This presentation is part of the playlist Integrals of Exponential Functions. In this presentation, we will be solving example problems related to integrals of exponential functions. Let us look at an example. Let us evaluate this function integral minus 10 e to the power of 2x dx. We're going to substitute 2x as equal to 2. Let us substitute u as equal to 2x. Okay. Differentiating u with respect to x, we have du by dx is equal to 2. Since u is a function of x, we can differentiate it with respect to x, and then du by dx translates to 2. So I can express this one as du as equal to 2 times dx, or if I have to express it in terms of dx, I can write it as 1 over 2 du. Now we can substitute u as equal to 2x, and then we can write dx as equal to 1 over 2 du into the given example problem, and then use the rules of integration and then solve this example problem. So our problem is integral minus 10 e to the power of 2x dx. Wherever we see 2x, we're going to replace it by u. So integral minus 10 e to the power of u, wherever we see dx, we can substitute 1 over 2 du like that. So by doing so, we can simplify it now. I have a minus 10 in the numerator, 2 in the denominator, minus 10 and then 2. 10 is the multiples of 2, so minus 5 is a constant, so I can take it outside of the integration process like that. Minus 5 integral, what we are left with is e to the power of u du as shown here. Now we are going to use the rules of integration to simplify this. We know that integral e to the power of u du is equal to e to the power of u. So therefore, I can write this one as minus 5 e to the power of u plus c, where c is a constant of integration. We need to express our solution in terms of x, not in terms of u. So therefore, wherever we see u, I'm going to rewrite that as 2x. So therefore, that is equal to minus 5 e to the power of 2x plus c, where c is a constant of integration. So this is the way we want to solve example problems, which involve integrals of exponential functions. Okay. Now let us look at another example problem. Let us say this time we want to evaluate a function integral t e to the power of minus t squared dt like that. So we're going to use the exponential rule and the rules of integration to solve this example problem. So let us substitute u as equal to minus t squared, and that is what we have here, minus t squared. So u is a function of t this time. Differentiating the function u with respect to t, we have du by dt is equal to minus 2t. d by dt of minus t squared is minus 2t to the power of 2 minus 1, which is equal to minus 2t like that. So I can rewrite this as du is equal to minus 2t dt. So if I have to express it in terms of dt, I can write it as dt is equal to minus 1 over 2t du. So now we can substitute u as equal to minus t squared and then dt as equal to minus 1 over 2t du into the given example problem, and then use the rules of integration to solve this example problem. So our example problem is minus integral t e to the power of minus t squared dt, right? So wherever we see minus t squared, we go to substitute it by u. So integral t e to the power of u, wherever we see dt, we go to replace it by this term here, minus 1 over 2t du, like that. So now by doing so, we have a t in the numerator, a t in the denominator, those cancel out. So I have a minus 1 over 2 as a constant. So I'm going to pull that outside of the integration process as shown. Then I'm left with e to the power of u du. So now we can integrate this using the rules of integration and then simplify it. So we know that integral e to the power of u du is equal to e to the power of u. So therefore I can rewrite this as minus 1 half e to the power of u plus c, where c is a constant of integration, right? So we need to express our solution in terms of t, not in terms of u. So therefore, wherever I see u, I'm going to replace it by minus t squared, and I can rewrite this as minus 1 over 2 e to the power of minus t squared plus c, where c is a constant of integration. This is the way we're going to solve example problems which involve integrals of exponential functions. In my next video presentation, we're going to solve more example problems related to integrals of exponential functions.